The next molecule we will look at are esters. So esters are molecules that are synthesized from the reaction of carboxylic acid and alcohol, are found in fats and oils, and are responsible for the aroma and flavors of banana, oranges, strawberries. All the artificial flavors that we have are esters. So again, these are some simple esters we are looking at. This is an acid, this is an ester. Remember, we said that esters are synthesized from acid and alcohol. So this is an acid, and when we replace the hydrogen with the alkyl group, we are creating an ester. Ethanoic acid, methyl ethanoate. So the ethanoic, ethanoate. The methyl is the alkyl group from the alcohol. So we'll get into the naming in a little bit, but esterification is the process of formation of an ester. Esterification is the reaction of a carboxylic acid and alcohol in the presence of an acid and heat to produce an ester. So again, we are looking at an acid, ethanoic acid, 2 carbons ethane, ethanoic acid, methanol alcohol in the presence of heat and acid. You are taking away a water molecule, OH, H. You're taking away a water molecule and connecting the 2 molecules. So this is your ester. When the hydrogen of a carboxylic group is replaced by a methyl group or an alkyl group, not methyl but an alkyl, you're creating a molecule of ester, and that is esterification. Now the methyl comes from the alcohol, the ethanoate comes from the acid. So there is an elimination of the water molecule in the process. An example of esterification is the reaction of ethanoic acid with 1 propanol to produce an ester called propyl ethanoate. Now this is responsible for the smell of pears. So this is ethanoic acid. This is propanol, 1, 2, 3, prop. So elimination of a water molecule, and you connect the 2 molecules. So propanol, propyl, ethanoic acid, ethanoate. So the name is propyl ethanoate, and this is responsible for the smell of pears. Write the equation for the reaction of propanoic acid and methanol. So the acid is propanoic acid, 3 carbon, methanol, METH, 1 carbon, alcohol. So we are going to set up the 2 molecules. This is propanoic acid, this is methanol, OH, H eliminated. You are connecting the 2 molecules, methanol, methyl, propanoic acid, propanoate, methyl, propanoate. The name. Now again, we said the name of ester consists of 2 words. The first word indicates the alkyl part of the alcohol. So this is the alkyl part of the alcohol. Here, methyl. The second word is the carboxylate name of the carboxylic acid. This is the carboxylic acid, 1, 2 carbons. Ethanoic acid, ethanoate, methyl alcohol, methanol, methyl. So methyl ethanoate. So then the IUPAC name, the acid is the carboxylate, the alcohol is the alkyl. So that's how you set up a name for an ester. Okay, ethyl ethanoate. So what does this tell me? Ethyl. So this is the ethyl. That tells me that the alcohol is ethyl alcohol. Ethanoate. ethanoic acid. Methyl propanoate, methyl. Methanol, propanoate, propanoic acid. You can see this should be a CH3. So if you see mistakes, we'll be able to figure the ethyl benzoate. Ethyl, this is ethyl. Ethanol, benzoic acid, benzoate. Now the link to health. Now this is in 1899, Bayer produced an ester of salicylic acid and acetic acid. This is aspirin called ester acetyl salicylic acid. So this is salicylic acid and this is acetic acid. So now this is the alcohol group, this is the acid. So it is connecting to the alcohol with the elimination of water, acetyl salicylic acid. So many people take daily dose of low aspirin, which has been found to lower the risk of heart attack and stroke. But aspirin, the chemical structure is acetyl salicylic acid. Now another oil of wintergreen or methyl salicylate has a pungent minty odor and flavor and is used in skin ointments, acts as a counter irritant producing heat to soothe sore muscles. So again, salicylic acid with methyl alcohol gives methyl salicylate or oil of wintergreen. So this is another link to health of salicylic acid from a willow tree. Naming esters. Write the name for the carbon chain from the alcohol as an alkyl group. Change the ic acid from the acid name to ate, ATE, carboxylate, tells you it's an ester. So let's look at this molecule and write the IUPAC name. So I'm looking for the alcohol, ethyl ethanol. This is 1, 2, ethyl, ethanol, 1, 2, 3. Propanoic acid. So ethyl, ethanol, ethyl, propanate, ethyl propanate, ethyl propanoate. That's how we name. The alcohol takes the alkyl group name, alkyl, ethyl, propanoate. Give the IUPAC a common name which responds to flavor or odor of pears. Okay. So I'm looking at this ester, and I'm going to count 1, 2, 3. This is my alcohol, propanol, so propyl, 1, 2. Ethanoic acid, so propyl ethanoate will be the IUPAC name, propyl ethanoate. Or propyl acetate is the common name, and this is the flavor or odor of pears. Many of the fragrances of perfumes and flowers and flavors of fruits are due to esters. So we can smell them. They are volatile. Volatile is they escape into the atmosphere fast, and they're soluble in water, so we can taste them. So esters in fruits and flavorings, propyl ethanoate, like we just discussed, is found in pears. Pentyl ethanoate, banana flavor. Octyl ethanoate, oranges. Ethyl butanoate, pineapple. Pentyl butanoate, apricot. So these are all esters found in fruits and flavorings. So now we are going into the study check. Draw the structures of the following compounds. 3-bromobutanoic acid. So now this is an acid and butanoic. But is 4. And if the carbon with the carboxylic group is number 1, number 3, starting from the carboxylic group, number 3 carbon has the bromo, and ethyl propanoate. So ethyl comes from the ethanol, and propanoate comes from the propanoic acid. Prop is 3. So 1, 2, 3, 3 carbon propanoate, and ethyl 1, 2 comes from the ethyl alcohol. And this is carboxylic carbon 1, 2, 3. 3 bromobutanoic acid. 1, 2, 3, 4. But. Ethyl, the alcohol group. Propanoate, propanoic acid, the acid. So esters are alcohol and acid molecules combined.